Okay, so before the break, I just defined to you how to find the first moment of area and the second moment of area. Okay, so I'm going to use this diagram, okay, which you can download from Avenue to Learn. And I want to describe about rule number 2. Okay. So rule number 1 is V and I are constants. Okay. So rule number 2 okay, rule number 2 is the geometric datum okay, the geometric datum is at the centroid. So what do I mean by that? What do I mean by that? Okay. So this means if you look at this figure down here, right? If this is my Vy, okay, let's look at this diagram down here, okay? And if this distance or this force is my Vy, right? The geometric datum, and this is our centroid, right? Right. The Z is our centroid based on Vy. So the centroid is also our geometric datum. So i.e. at this point over here, right? Y is equal to 0, okay? Right? Because it's a datum, right? And at this from here to here, right? This distance, this is our Y max. Okay. Now, if we were to flip this over, so this is based on Vy. Okay, so what I've drawn is based on Vy, right? If it's Vx, I'll copy and I'll paste down here again. All right. So now if this is our Vz, excuse me. Right? Then our centroid is over here. Right? And this centroid, excuse me, is our geometric datum. Okay, and this is our this point is our Z is equal to 0, and this distance from here to here, that is our Z max. Okay, so that's rule number 2. So you know where to datum. So if you want to view it, you can say that the datum or not view it, the datum is also always at the centroid. Okay, depending on where the applied force is applied. Rule number 3. The analysis direction okay, the analysis direction starts at the maximum distance relative to the centroid. Okay, so what do I mean by that? So coming back to this diagram over here, right? the analysis direction starts from, okay, not at, sorry, from the maximum distance relative to the centroid. So what it means that over here, right, in this diagram where you see this is our Y max. So the analysis starts from here and then move inwards. Okay, so it moves towards the what? The centroid. Okay, so it starts at the maximum relative to the centroid and moves towards the centroid. Okay. So likewise, if it's in the VY direction, right, the centroid or the analysis direction is this way. Okay, it starts from Y maximum. Okay, so this is the analysis direction. Okay, so likewise, over here, this arrow over here is the analysis direction. And rule number 4, a very important rule, is that the first moment of area, rule number 4, is that the first moment of area region, okay, cannot cross or intersect, okay, or intersect the centroid. Okay. So rule number 4, I'm going to give examples, okay, on what do I mean by this, okay. So rule number 1, V and I are constant. Rule number 2, the centroid, the datums at the centroid. Rule number 3, the analysis start from maximum distance from the centroid. Rule number 4, the first moment of area cannot cross or intersect the centroid. Okay. Let's see how this behave there. Okay. Okay. So now, I'm going to give some example. Now, some of you will say, Eugene, how do you come up with these rules? Okay, how these rules are developed. So these rules are developed. Okay, I don't want to waste time because if I spend time deriving it, I cannot show you more examples. Okay, so these rules, so this is what I taught last term. Okay, so these rules are derived mathematically. Okay, it's the math. Okay, so I don't want to go to the math down here. Okay, I find like it can be very taxing and not enough time. Okay, so this is the math. Don't worry about the math yet. Okay, don't worry about the math. Okay, I just tell you the rules. I'm going to show you how it's applied. I just mentioning this is the rules are derived from mathematics. Okay, so I think I just mentioned the rules and then I teach you how to apply. I think it's more important as your term test is next week. Okay, so now go back to where we were. Right. So I'm going to draw a transformation now. Y, Z, rotation about X. Okay. So we are going to find, okay, the shear stress. Right. So the shear stress in the XY direction is equal to the shear stress in the YX direction. And because of what I'm going to draw now, I'm going to change a bit of no need. Okay, so let's say this is the diagram. Okay. Right. This is our cross-sectional area, and this is our Vy. Okay, so we know that this is equal to Vy over Izz Qz multiplied by T. Okay, so this is our centroid. Okay, so this is our centroid. ZZ. Okay. If we want to find our stress at this point, okay, and this is our alpha point, right? We have to obey all the 4 rules to see how are we going to determine our first moment of area or how to apply. So rule number 1, right? V and I are constant. So what this means, okay? So this means if we put in the formula where shear x, y, and we want to find at alpha, so V over I are constant. So whatever you find out, I can give you any point, V and I are constant, okay? Then rule number 2, right? Geometric datum is at the centroid. So this is our datum. So this is our date. So the symbol for datum is like that, yes or no? Okay, so this is our datum. Okay, and this at this point is where y is equal to 0. Okay, and then the analysis starts from y max. Right? So we know that this is your y max. Now the question is, which is the area to consider? Right? So based on rule number 3, the analysis direction is coming down from this direction. This is analysis. Right? And y max starts from or the first moment area is taken from y max. So this is the area of interest. Okay, so this is the area. This is how you calculate your QZ, which is equal to A y bar, and the distance from here to here is your y bar. Okay, so y bar is relative to the cross-sectional area centroid. Okay. Now, for this case, we don't need to trigger rule number 4 because it did not. So rule number 4, first moment of area Q cannot cross the centroid. We did not break rule number 4. It's still valid. The first moment of area cannot cross the centroid. Now, what will happen now? So this is straightforward. Okay. Now, what will happen now? So same diagram. Okay, same diagram. Okay. And then we have our ZZ. Okay. I still want to find alpha, but now Vy starts from the bottom. Okay. It starts from the bottom. The shear force is going upwards. Question for you. What is the area that we consider? Anyone? So I give you options, okay? Is it this area that we consider? Wait. Okay, I give you option. Is this the area that we consider? Now, if I shade like this to consider the area, first moment of area, which rule did we